Solar UHU 180 Graupner. First test. Today, hello YouTubers, thank you for watching. Today I'm gonna try to, it's already 2 p.m. but I'm gonna try to test the solar UHU with the direct solar cells and with the charging nickel cadmium 4 cells, 240 grams. So parallel cable and a small DC watt meter. It shows you how much electricity I put to the battery and how much electricity I put through the motor, and with charging and without charging we're gonna test everything. So of course first we're gonna hook up the solar cells. So the 1, 2, 3, 4, 5, 6 solar cells and 6 solar cells on the other half of the wing, of the left and right wing. They hooked up in serial, so altogether they should be around 7 volts. So you're gonna hook up this first. So it is around 7 volt. And now we're gonna try to directly hook up to the motor or the model. Initialized, so it draws about 100 milliamps and 695 already. So now we're gonna try to see the power of it. It's about 3.7 amp, 5.5 volt under load, right? So it gives you roughly 20 watts only. So it's not much, right? If I put shade to the, see, just one of it, so the power goes down immediately. So it's very sensitive to the shading. Even one cell is gonna, the power is gonna be affected. Even if you just shade the walls one cell. If you go higher, you can go up to 4 watts. Actually, almost 4 amps, around 20 watts. Right. And that's not 90 degrees. The sun is really powerful, but still. Actually, we should check it under, like, maybe
time remaining,
maybe
9
holding it
minutes.
Like really up. That's okay, that's okay. It's still 3.8 amp, 20 watts, and of course you have a full. That's good, but the model is 1.2 kilograms. And also CG is not correct, so I have to put this weight. And also when you fly and when the clouds are up and the sun is not available, then you might lose a control. That's why we're gonna parallelly hook up now this guy here. So now basically we're gonna be charging. See?
Time remaining
2.9, 2.8, 2.2, 2.6, 2.7 amps, 6.4 volt. Basically that's the current, charging current, and the voltage goes parallelly to the motor. Of course there is no load, maybe 100 to 100 milliamps right now through this thing, and it's divided to parallelly charge the battery, which is 4.8, but it's basically 1.2 nickel cadmium nickel metal hydrate. It gives you 6 volts, so 5.8 volts at 3 amps. Now we're gonna start and try basically how it flies. See? Now we can go a higher voltage, high amperage. 4.5 volt, 4.6, 2.3, 10 watt only. And when you stop, it's gonna be continuing solar charging the batteries which are here, and it's exactly CG, should be right, should be correct. So 2.9, 3 amp charging current at 5.6 volt. So one overcharging is not likely because nickel metal hydride batteries are not so sensitive like lithium ion. So I'm not using, I'm just testing, I'm not using it as a charge controller or anything, just trying to see how much power actually you can get. It doesn't seem right. It seems like 15 watt, 14 watt charging power, 2.6, 2.5 amp at 6 volts, so voltage is going high, of course, so it is charging the batteries. And direct solar was like 20 watts, so basically this should be at least 30 watt. And of course,
Time remaining 6 minutes. Timer cleared.
of course, when you put this battery on the right spot, the CG should be right, and it gives like 240 grams and 1,200 grams, 1.2 kilos, 2 grams, 200 grams. It gives you roughly the weight, flying weight, 1.4, 1.5 kilos. So it's not that heavy because its wingspan is really big. It's 1.8, and this is only like not really aerodynamic, but I might try it outside today because it's really sunny, almost no clouds, and it's really powerful. Let's try one more time. Okay, maybe I was like this.
Timer start.
So, oh yeah, now there is a cloud. Now we're gonna see what happens. See, because we have a battery, we are safe. Because right now, if you just use the solar power would be probably dropping below 6 or 4 volt on the load, even without load, and then we're gonna be losing control. That's why it's not really very clever to just use it unless you have a smaller battery as a backup. Receiver battery.
Time remaining 9 minutes.
It's not bad. Okay, let's try now, because sun is not very favorable, to completely unhook the battery. See? Now sun is getting out. Cloud is moving away and the amps are going up. See? I stopped it, but it's still 6 volt. But if you go, see, it's struggling. It's at 3.5 volt. So it's right on the level when you're gonna lose control, because anything below 4 volt, now it's 5 volt because sun is out. Small cloud is away.
Time remaining 8 minutes.
2.9, 21 watts. So 21 watts, about 20 watts. Now you can restart it easily, but it's 7 volt. So anytime you go under 5 volt, it's gonna be trouble to regain control. You risk losing the model. It's not bad. So that's enough testing for. It's time to go on the flying field and try it. It's gonna be heavy, 1.5 kilos. It's not that heavy, but we're gonna try it. Thank you for watching. Bye bye.